Hi there, I'm Pete Mattock, and this is one of my videos exploring the understanding behind maths hacks. The internet is awash with maths hacks and tips and tricks to help people do maths. But if anybody knows anything about my work, then you'll know that I'm very passionate about people not just being able to do maths, but understanding why the maths that they're doing actually works the way it does. Now, in this hack, we're going to explore squaring numbers very close to 100, like this number here, 94 squared. And the way this hack works is to say, right, well, because 94 is close to 100, let's look at how far away from 100 it is. Now, 94 is 6 away from 100, 6 less than 100. So to make this hack work and to square this number quickly, what I'm going to do is say, right, well, let's take that 6 and subtract it from the 94. That gives us 88. And then we take the 6 again, but we square the 6, just like we were squaring the original 94. And 6 squared is 36, so we put that 36 on the end of 88, and we get the number 8,836. And that is actually 94 squared. If you were to put 94 squared into your calculator, you would get 8,836. So it's quite a nice hack. Just take the 6 off the 94 and then square the 6 and stick that on the end. And it works with numbers other than 94. It works with all numbers that are relatively close to 100. But let's see if we can get at why this works. Now, there are a couple of ways of making sense of why it works. The way I'm going to choose is to bring that 100 back in. Yeah, so the reason we subtracted 6 was because it was 6 away from 100, because our 94 was 6 away from 100. So I'm going to bring that 100 back in, and I'm going to say, okay, well, let's write 94, not as 94, but let's write it as 100 minus 6. So let's think not about squaring 94, but squaring 100 minus 6. Now, 100 minus 6 is 94, so these two things are the same. So whatever we get from here, we should also get from there. Now, because we've got a binomial here, an expression with two terms, if we are squaring a binomial, then that's going to happen in stages. And so if I want to square this 100 minus 6, to square that out, I'm going to say, right, well, first of all, I've got to square the 100. So I'm going to have 100 squared. And then I've got to have twice the product of these two things. So 2 times negative 6 technically is how we treat that, but I'm going to put the negative in front so it becomes a subtraction, and that's perfectly valid. So 2 times 6 times 100. So we've squared the first thing. We've got twice the product of those two. And then the last stage of that expansion is to square the last thing. And although technically the last thing is negative 6, the square of negative 6 and the square of positive 6 are the same, because a negative multiplied by a negative results in a positive. So although I should be squaring negative 6, that's just the same as squaring 6. Now, that plus 6 squared is important here, because it's that plus 6 squared which is where we get this 6 squared from at the end of the hack. Yeah, the fact that we took the 6 that we subtracted from the 94 and squared it and stuck it on the end. That's where that part of the hack works, and that's why part of the hack is sticking 6 squared on the end. So what about this 88? Well, let's look at the rest of this expansion that we've got here. 100 squared minus 2 times 100. Now, if we think about 100 squared as 100 times 100, then what we've got here is 100 times 100 minus 2 times 6 times 100. And both of those have a factor of 100. Yeah, both of those are 100 times something. So I'm going to write just that top part of my expansion as a refactorized form as 100 times something. So I'm going to take that and write it as 100 times terms. And then it's about, okay, what do I multiply 100 by to get each of these two terms? Well, to get 100 squared, I need to multiply 100 by 100. 100 times 100 makes 100 squared. And then what about to make this second bit? Well, the second bit, if we keep the minus sign in place, is 100 times 2 times 6. So if I've got my 100 out here, it's 100 times 2 times 6. And that's that top line of the expansion rewritten with the factor of 100, the fact that both terms of that part are 100 times something, with that factor of 100 written in front. And then, of course, not forgetting that we need to keep our plus 6 squared. We don't want to lose that, but we're not focused on it at this point. And what we can see now is, because this thing is being multiplied by 100, this bracket here is being multiplied by 100, that's going to mean our eventual number for this part is a multiple of 100. In other words, it's going to have 2 zeros in that place, and those 2 zeros are going to be nicely filled by this 6 squared. So let's see why it's 88 that ends up taking that place. Well, if we look at what we've got in the bracket now, and this is really key to the whole hack, you've got 100 minus 2 6s. You've got 100 minus 2 times 6, 100 minus 2 6s. And if we think back to our hack, we had 94 minus 6, and the reason we subtracted 6 was because 94 was 6 less than 100. So in effect, what we're doing in this hack is saying, well, where's 100? What do I subtract from 100 to make 94? 6. Subtract that again. And that's exactly what we see in this bracket here. Here's the 100. What am I subtracting? 6 to get to 94, but I'm doing it again. I'm doing that twice. So I'm going to rewrite this now one more time, keeping that 100 factor in the front. But rather than writing 100 minus 2 times 6, I'm going to bring back that 94 and say, well, if I subtract one of these 6s from the 100 to get 94, I got only 1 6 left to subtract. So here we've done 100 and we've minused one of these 2 6s to get this 94. And therefore we've got 1 6 left to subtract. Plus, as always, our 6 squared. And now we can see the whole of this hack, yeah, because we can see that we're doing 94 minus 6. That's the bit there. That's giving us our 88 in this case, but obviously with other numbers it would give us other things. We're then multiplying that by 100, which is shuffling the 88 up those 2 places to make it not 88, but 8800, 8,800 or 8,800. We've got 8,800 literally there. And then finally, this 6 squared that has come all the way through our expansion goes on the end because it fills those last 2 places. So we add that 6 squared at the end. And that's why this hack works. Now, I'm going to be exploring plenty more maths hacks and understanding why they work. But if you've got a maths hack that you've come across in the internet, or a tip or a trick or something like that, and you're interested in why it works, then please do drop me a message or reach out to me in the comments.